11. Lines and angles. Introduction. In Class 6, we have learnt about lines and angles and their measurements. Let us review in brief what we studied there and then learn about some properties of angles. Recall that a line segment has two endpoints. If we extend the two endpoints in either direction endlessly, we get a line. Thus, a line has no endpoints. On the other hand, a ray has only one endpoint, which is its starting point. A line segment AB is denoted by a ray AB is denoted by angle. A figure formed by two rays with the common initial point is called an angle. The common initial point is called the vertex of the angle, and the rays forming the angle are called its arms or sides. In the given figure, QP and QR are the two arms, and Q is the vertex of the angle PQR. We denote it as angle PQR, interior and exterior of an angle. In the adjoining figure, points Q and R are in the interior of angle AOB. Points A, B and U are on the boundary of angle AOB, and points P, S and T are in the exterior of angle AOB. Types of angles. Straight angle. If two arms of an angle lie along the same straight line but point towards opposite directions, then the angle is called a straight angle. A straight angle always measures 180 degrees. Acute angle. An angle whose measure is greater than 0 degree but less than 90 degree is called an acute angle. Obtuse angle. An angle whose measure is greater than 90 degree but less than 180 degree is called an obtuse angle. Right angle. An angle whose measure is 90 degree is called a right angle. Reflex angle. An angle whose measure is greater than 180 degree but less than 360 degree is called a reflex angle. Pairs of angles. In geometry, we often come across pairs of angles. They have been given specific names. Adjacent angles. If two angles have a common arm, a common vertex, and their other arms lie on the opposite sides of the common arm, then the angles are called adjacent angles. In the given figure, angle AOB and angle BOC are called adjacent angles. Rays OB is the common arm and O is the common vertex. The arms rays OA and rays OC are on the opposite sides of rays OB. Also, angle AOC is equal to angle AOB plus angle BOC. Linear pair of angles. If a ray stands on a line, then the two adjacent angles so formed are called linear pair of angles. In the given figure, AB is a line and OP is a ray standing on line AB. Angle AOP and angle BOP are adjacent angles and they form linear pair of angles. From the figure, angle AOP plus angle BOP is equal to angle AOB. This implies angle AOP plus angle BOP is equal to 180 degree. Since angle AOB is a straight angle, it implies that two adjacent angles will form a linear pair of angles if the sum of these angles is 180 degree. Complementary angles. If the sum of the measures of two angles is 90 degree, then the angles are called complementary angles and each angle is called a complement of the other. Thus, angle A and angle B are complementary if angle A plus angle B is equal to 90 degree. In the above figures, angle ABD and angle DBC are complementary angles since angle ABD plus angle DBC is equal to 90 degree. Supplementary angles. Two angles are said to be supplementary angles if the sum of their measures is 180 degree and each angle is called a supplement of the other. Supplementary angles may or may not be adjacent. In the above figures 1 and 2, angle PQR and angle RQS are supplementary angles, since angle PQR plus angle RQS is equal to 180 degree. Vertically opposite angles. When two straight lines intersect each other, then the pairs of angles so formed without any common arm are called vertically opposite angles. Let PQ and RS be two lines which intersect at O. Thus, four angles have been formed. Angle 1 and angle 3 form a pair of vertically opposite angles. Also, angle 2 and angle 4 form another pair of vertically opposite angles. From the figure, angle 1 plus angle 2 is equal to 180 degree, since angle 1 and angle 2 form a linear pair. Therefore, angle 1 is equal to 180 degree minus angle 2. Equation 1. Also, angle 2 plus angle 3 is equal to 180 degree, since angle 2 and angle 3 form a linear pair. Angle 3 is equal to 180 degree minus angle 2. Equation 2. From equations 1 and 2, we get angle 1 is equal to angle 3. Similarly, we can prove angle 2 is equal to angle 4. Thus, if two lines intersect, then vertically opposite angles so formed are equal. Example. State which of them is acute, right, reflex, and obtuse angle. Solution. Angle A is an acute angle, being less than 90 degree. Angle B is a right angle, being 90 degree. Angle C is a reflex angle, since it is more than 180 degree. Angle D is an obtuse angle, since it is more than 90 degree and less than 180 degree. Pairs of lines. We shall now study about intersecting lines, transversal and parallel lines, also angles made by a transversal with two lines. Intersecting lines. Two lines, L and M, intersect if they have a point in common. This common point is called the point of intersection. In the given figure, two lines, L and M, intersect at O, which is the point of intersection. Transversal. A line which intersects two or more given lines in a plane at different points is called a transversal to the given lines. In each of the figures given below, L is a transversal. Parallel lines. Two lines in a plane are parallel if they do not meet when produced infinitely in either direction. The opposite edges of a room, the opposite edges of a blackboard, railway lines, the opposite edges of a ruler, etc., are all examples of parallel lines. In the given figures, L parallel to M or M parallel to L. The perpendicular distance between two parallel lines always remains the same. Angles formed by a transversal with two lines. Let L and M be two lines and N be a transversal intersecting L and M at P and Q respectively. Clearly, lines L, M and N make 8 angles. In the given figure, these 8 angles marked 1 to 8 have their special names. Interior angles. The angles whose arms include line segment PQ are called interior angles. In the given figure, angle 3, angle 4, angle 5 and angle 6 are interior angles. Exterior angles. The angles whose arms do not include the line segment PQ are called exterior angles. In the given figure, angle 1, angle 2, angle 7 and angle 8 are exterior angles. Alternate interior angles. A pair of angles in which one arm of each of the angles is on the opposite sides of the transversal and the other arm is segment PQ is called a pair of alternate interior angles. Thus, in the given figure, angle 3 and angle 5, angle 4 and angle 6 form pairs of alternate interior angles. In short, alternate interior angles are also called alternate angles. Alternate exterior angles. A pair of angles in which one arm of each of the angles is on the opposite sides of the transversal and the other arm in opposite direction and do not include line segment PQ is called a pair of alternate exterior angles. In the given figure, angle 1 and angle 7, angle 2 and angle 8 form pairs of alternate exterior angles. Corresponding angles. A pair of angles in which one arm of each angle of a pair is on the same side of the transversal and the other arms of the angles of the pair are directed in the same direction are known as corresponding angles. In the given figure, 4 pairs of corresponding angles are angle 1 and angle 5, angle 2 and angle 6, angle 3 and angle 7, angle 4 and angle 8 are corresponding angles. Angles made by a transversal to 2 parallel lines. When 2 lines are cut by a transversal, 8 angles, 4 pairs are formed. These pairs of angles have special properties if the lines are parallel. Let L and M be 2 parallel lines and N be the transversal intersecting L and M. The transversal makes the following 8 angles as shown in the figure: angle 1, angle 2, angle 3, angle 4, angle 5, angle 6, angle 7 and angle 8. If we measure those angles with the help of a protractor, we find that angle 3 is equal to angle 5 and angle 4 is equal to angle 6. These are alternate interior angles. Angle 1 is equal to angle 7 and angle 2 is equal to angle 8. These are alternate exterior angles. Angle 1 is equal to angle 5, angle 2 is equal to angle 6, angle 3 is equal to angle 7, and angle 4 is equal to angle 8. These are corresponding angles. Angle 3 plus angle 6 is equal to 180 degree, and angle 4 plus angle 5 is equal to 180 degree. Angle 3, angle 6, and angle 4, angle 5 are 2 pairs of interior angles. This implies that sum of the interior angles on the same side of the transversal is 180 degree. Angle 1 plus angle 8 is equal to 180 degree, and angle 2 plus angle 7 is equal to 180 degree. Angle 1, angle 8, and angle 2, angle 7 are 2 pairs of exterior angles on the same side of the transversal. Thus, we observe that when a transversal is drawn to 2 parallel lines, the following properties of the angles are formed. Property 1. Pairs of alternate interior or exterior angles are equal. Property 2. Pairs of corresponding angles are equal. Property 3. The sum of the interior or exterior or corresponding angles on the same side of the transversal is 180 degree. Conversely, if a transversal intersects 2 lines such that any one of the following conditions hold: a pair of alternate angles are equal, a pair of corresponding angles are equal, the sum of the interior angles on the same side of the transversal is 180 degree, then the 2 lines are parallel. The following examples illustrate the application of above properties. Example: in the given figure, DE parallel to BC, find the values of x and y. Solution: since DE parallel to BC and AB is transversal, therefore angle x is equal to 50 degree. Alternate angles. Again, DE parallel to BC and AC is transversal. Therefore, angle y is equal to 60 degree. Alternate angles. Hence, angle x is equal to 50 degree and angle y is equal to 60 degree.